In this video, we'll find the number of protons, neutrons, electrons, and the mass number for silicon. So silicon has three primary stable isotopes, and we're going to look at each one of these. More about isotopes later, though. Let's fill in the information for this table that we do know about the protons, neutrons, electrons, and mass number for silicon. So it has atomic number 14. So each one of these isotopes, it'll have an atomic number of 14. That's what silicon, that's the definition for silicon. It has an atomic number of 14. And that just means the atomic number, that's the number of protons. So each of these isotopes will have 14 protons. When we look at the periodic table, we see Si here. So Si, that's our silicon. And this is a neutral element. All the elements on the periodic table are neutral. If it had a charge like a plus or a minus, then it would be an ion. But Si, that's a neutral element. And with neutral elements, number of protons equals the number of electrons. So for each one of these, 14 electrons. Pretty easy so far. We're left with two columns, neutrons and mass number. So neutrons, that's the only thing that is different with isotopes of silicon. So they all have 14 protons. If it's neutral, they all have 14 electrons. But the neutrons, that's what's going to be different, and that's what makes them isotopes. Since protons plus neutrons gives us mass number, the mass number will be different too. Often with these tables, you'll be given either neutrons or a mass number, and you can figure the other one out. If not, though, look at the periodic table and look at the average atomic mass. We'll take that number and round it. So we're going to take this 28.09, let's round that to 28. Now, we could say that the mass number, 28, equals the number of protons, that 14, plus the neutrons, which we're trying to figure out. So something plus 14 is 28, 14 plus 14. So we have 14 neutrons. So protons plus neutrons, that gives us our mass number. And we name this silicon-28 based on its mass number. So this is the most common isotope of silicon. If you had a sample, a big block of silicon, about 92% of the atoms would be this isotope. They'd have 14 neutrons. There are two other stable isotopes. One has a mass number of 29. This is about 4 or 5% of the atoms in a sample of silicon. They'll have this mass number. So something plus 14 equals 29. 15 plus 14. So we can put 15 there, and we have our mass number of 29, so we call this silicon-29. There's one more stable isotope that's about 3%. That's silicon-30. And let's say mass number is 30. So 16 plus 14, that gives us 30. So these are the three isotopes. What you can tell by looking at the periodic table, because this number here is an average of these three isotopes based on their abundance, how much there is. Because it's closer to 28, that means most of the sample will have a mass number of 28 and 14 neutrons. So the isotope will be silicon-28. But there will be some of these other isotopes. You can't really look at the periodic table and tell how many stable isotopes there will be, but you can tell kind of which one will be the predominant isotope. In this case, mass number 28 is closest to the average atomic mass. We can write the notation for each isotope using what's called nuclear notation. So we could put 28 as the mass number up here, and then 14 the number of protons. So this is silicon-28. We could do Si-29, and because it's silicon, it has 14 as its atomic number. And then we have one more, let's do 30, 30, and again it's 14 here. So these are the three isotopes of silicon, and this is the nuclear notation that shows each specific one. On the periodic table, you get an average of these isotopes based on how much there is, on its abundance. This is Dr. B with the number of protons, neutrons, electrons, and the mass number for silicon. Thanks for watching.